In this video, I'll be solving the first part of the third question of UPSC Civil Services Mains Statistics Paper 1. So, we're given the single observation PMF, like where f of x given theta is theta by 2 whole to the power mod x into 1 minus theta whole to the power 1 minus mod x, for x is minus 1, 0 and 1. So we need to check whether x is a complete sufficient statistic, and we also need to check whether mod x is a complete sufficient statistic. And f of x given theta, does it belong to exponential class? And finally, we also need to find the maximum likelihood estimation of theta. So f of x given theta here is x given theta is theta by 2 whole to the power mod x into 1 minus theta whole to the power 1 minus mod x. And x belongs to minus 1, 0 and 1. 0 less than or equal to theta less than or equal to 1. So probability of x is equals to 0 is nothing but 1 minus theta. Probability of x is equals to 1 is theta by 2. And probability of x is equals to minus 1 is also theta by 2. So therefore, like probability of mod x is equals to 1 is just theta by 2. And is theta. So now first, we need to check whether x is a complete sufficient statistic. So if we try to see this entire PMF, the probability mass function is depends on the sample only through that mod x. So by using factorization theorem, we can say mod x is sufficient statistic for theta, because if we find the likelihood function, it factorizes as a function of mod x and theta times a function which is not involving that theta. And if we see the complete data, the full datum x, so that is trivially sufficient too, because the data itself is always sufficient. But it is not minimal sufficient statistic because model depends on x only through this mod x. So therefore x is sufficient as well, but not minimal sufficient. So now regarding the completeness, so x takes three values, minus 1, 0 and 1. So in order to test the completeness, let's take a of x be any function with expectation of theta, a of x. So that would be 1 minus theta into a of 0 plus theta by 2 a of 1 plus theta by 2 a of minus 1 is 0. For all, this must be 0 for all theta belongs to 0 to 1. So if we rewrite this function by rearranging the terms, a of 0 plus theta into a of 1 plus a of minus 1 by 2 minus a of 0 must be equal to 0 for all theta. So this implies the coefficients of the constant term, that is a0 is 0, and the coefficient of this theta, that is a of 1 plus a of minus 1 by 2 minus a of 0 is 0. That means a of 1 plus a of minus 1 is 0. So that means based on these constraints, they are allowing non-zero choices. For example, I can take a of 1 as 2 and this as minus 2 and create a function. So basically a non-trivial function has zero expectation for all theta. So that means x is not complete, though it is sufficient, but sufficient. Again, not minimal sufficient. Now if we take mod x, so mod x is taking only two values. So unlike this x value, so mod x is taking only two values, which are 0 and 1. So if I consider b of mod x as a function, so where b of 0 is u and b of 1 has some v, so expectation of theta of b of this mod x is 1 minus theta into u plus theta into v, which is u plus theta into u minus v. So this equals to 0 implies u must be 0 and u minus v also must be 0. That means u is equals to v, that means v is equals to 0. So that means only this trivial function, so only the trivial function 0 is satisfying, only this trivial function 0 has the 0 expectation. So that means mod x is complete. So therefore we can see mod x is sufficient and complete, and in fact it is minimal sufficient as well. Whereas if we are having x, so x is just sufficient but it's not complete, but not complete. So that's the first part. So that's what we are asked us to, they have asked us to check in the first part. Now in the second part, we need to check whether f of x given theta belongs to exponential class or not. So in order to do that, f of x given theta, we are given it as theta by 2 whole to the power mod x into 1 minus theta whole to the power 1 minus mod x. That is exponent of log theta by 2 whole to the power mod x plus log 1 minus theta whole to the power 1 minus mod x. And that is nothing but exponent of mod x into log theta by 2 minus log mod x into this 1 plus theta to log 1 minus theta. So that is nothing but exponent of mod x into log theta by 2 minus log 1 minus theta plus log 1 minus theta. So we can clearly see it's this is like one of the one parameter exponential family form. So this is our f of x given theta. So whereas if we compare with the form f of x given theta will be of the form some h of x into exponent of this n of theta into t of x minus a of theta. So we can see like the natural statistic here is this mod x, and so the likelihood for this, so so this f of x given theta, this belongs to exponential class. Now in order to find in the third part, like we have to find like whether this is whether this is following this maximum, like we need to find the maximum likelihood estimate of theta. So in order to find the maximum likelihood estimate of theta, so likelihood for a single observation, like first we can write for a single observation L of theta given x. So we have like f of x given theta is theta by 2 whole to the power mod x into 1 minus theta whole to the power 1 minus mod x for x minus 1, 0, 1, and 0 less than or equal to theta less than or equal to 1. So L of theta comma x is nothing but 1 minus theta when x is 0, or it's theta by 2 when x is 1 or x is minus 1. So that means if x and 0 less than or equal to theta less than or equal to 1. So that means if x is equals to 0, our likelihood is 1 minus theta, and this is decreasing on theta. This is decreasing in theta on this theta to 1. So that means the maximum is occurring at the boundary. So theta hat MLE in this case would be 0. Now if x is plus or minus 1, so or like mod x is equals to 1 case, L of theta is theta by 2, which is increasing in theta. On this 0 to 1. So theta hat MLE will in this case would be 1. So therefore our MLE would be 0 if x is 0 and 1 if x is 1 or x is equals to minus 1. So that's the maximum likelihood estimate of this theta. So that's it for this video. We'll meet in the next video.